I will run, I will climb, I will soar. I'm undefeated.
Assalamualaikum and hi everyone. We begin syllabus SM025 with chapter 1, integration. Now we look at subtopic 1.1, integration of function. In this subtopic, students should be able to relate the integration and differentiation, define basic rule of integration, find the integral of e power of bx plus c, 1 over bx plus c, and a power of bx plus c. And students should be able to find the integral of the form f prime x over fx, f prime x times e power of fx, and f prime x times fx power of n. Okay, the integration of function. What is integration? Integration is the reverse process of differentiation. In differentiation, we start with an expression and then proceed to find its derivative, which is we learn in SM015, chapter 9. In integration, we start with the derivative and then work back to find the function from which it is derived. The process of finding antiderivative is called antidifferentiation, or we know as integration. If differentiation capital Fx equals to Fx, then the function of the form capital Fx plus c are the antiderivative of Fx. We denote this by writing as statement 1. The symbol is called an integral sign, and the statement 1 is read as the indefinite integral of fx equal capital Fx plus c. The constant c is called the constant of integration. Okay, now first we look at the basic rule of integration. First, integrate a constant k with respect to dx. Okay, we're gonna have kx plus c. We just add x to k and plus c, where c is the constant. Second, integrate x with power of n with respect to dx. We have x with power of n plus 1 divided by n plus 1 plus with constant c, where n is not equals to negative 1. And third, integrate constant k multiplied with a function fx. So we can put k in front and just integrate the function fx. Rules number 4. Integrate fx plus or minus with another function gx. So we can separate two functions, which is we integrate different separately. Integrate fx plus or minus integrate function gx with respect to dx. And rule number 5. Integrate ax plus b with power n. Okay, polynomial with a power n. So we're gonna get ax plus b with power n plus 1 divided by n plus 1 times a, and don't forget plus c, and this is for n not equals to negative 1. So this is a basic rule of integration where we can directly integrate of the function. Okay, now we look at the example for a further explanation. Find the following integral. For example A, integral a constant 3 dx. Okay, to integrate the constant, we have refer the integration with respect to. So this integration is with respect to dx. So the answer is we just put the x and don't forget plus with t. So integrate a constant 3, we have 3x plus c. So for another example, let's say we integrate pi, a constant pi, with respect to dy. Okay, so by rule number 1, so we're gonna have pi y, since the integration is respect to y. So we're gonna have pi y plus c. Okay, for example B, integrate x power of 6 respect to dx. So according to rule number 2, so we just x and the power 6 we just plus 1 and divided by 6 plus 1, and don't forget plus c. So we just simplify this, so we have 6 power of 7 divided by 7 plus c. For example C, we have integral negative 2 sec x dx. So since negative 2 is a constant, so according to rule number 3, I can put out negative 2 and just integrate sec x dx. So sec x I can write as x power of 1 over 2. Okay, so we have integral x power of 1 over 2, then we have x 1 over 2 plus 1 divided by 1 over 2 plus 1, and don't forget plus c. So I have x power of 3 over 2 divided by 3 over 2. Okay, so negative 2 is divided by 3 over 2, so I have negative 4 over 3, x power of 3 over 2 plus c. That's our final answer. And for example D, integrate 2y plus 1 power of 2 over 3 respect to dy. According to rule number 5, okay, we can directly integrate. So we have here as 2y plus 1, okay, with power n 2 over 3, so we just added 2 over 3 plus 1 divided by 2 over 3 plus 1. And for a polynomial, we have to multiply with a differentiation of 2y plus 1, which is 2. Okay, and don't forget, after we do an integral, we have to put plus c for a definite integral. And we just simplify this equation as 2y plus 1 power of 5 over 3 divided by 5 over 3 times 2. Okay, so this divided by this fraction, so we can multiply by 3 over 10, 2y plus 1 power of 5 over 3. Okay, now we look the integral of exponential, which is in the form, the basic form e power of x, 1 over x, and a power of x. Okay, first we have integral at e power of x dx. Okay, so the basics e power of x, we're gonna have ex, e power of x plus c. For the integral e power of ax dx, we have 1 over a times e power of ax plus c. And for integral of a power of x dx, we have 1 over ln a times a power of x plus c. And if we have integral in the form a power of bx plus c, the integral would be a power of bx plus c divided by ln a times b plus c, where b is the coefficient of x. Okay, that's the basic integral in the form exponential function. Okay, for a special case of integral x power of n when n equals to -1, it should be remembered that differentiate of ln x equals to 1 over x. Therefore, reversing the process give integral of 1 over x equals to ln x plus c. So in general, we can conclude that integral of the form 1 over ax plus b will be 1 over a times ln ax plus b, and don't forget plus c. Okay, or we can write as ln ax plus b over a. Okay, that's the basic integral of exponential and 1 over x. Okay, for further explanation, we look at example 2. Find the following integral. For example A, we have integral of e power of -2x dx. Okay, so we have e -2x divided by the constant -2, and don't forget plus c. Or we can write as -1 over 2 e -2x plus c. Okay, either one. For example B, have integral 5 power of 2x minus 3 dx. Okay, so according to the basic rule, we have 1 over ln 5 times 2, okay, times with 5 power of 2x minus 3 plus c. Or you can write as 1 over 2 ln 5, 2x minus 3, or you can write over 2 ln 5 plus c. Okay, all the answer are in the correct form. Okay, for example C, we have integral 1 over 5 minus 3x dx. Okay, you cannot bring 5 minus 3x uh, to the numerator because the equation would be 5 minus 3x power of -1. So we cannot integrate with n equals to -1. Okay, so for this we have to remain the equation as 1 over 5 minus 3x. Okay, so we're gonna have 1 over -3 ln 5 minus 3x plus c. Okay, we're following the rule of 1 over ax plus b. Okay, we have 1 over a ln ax plus b and plus c. Okay, this is basic integration of 1 over ax plus b. Okay, now we look at the integral of in the form f prime x over fx. Okay, from the previous note, we see that a differentiation of ln ax plus b equals to a over ax plus b. So, in general, differentiation of ln of a function fx, we have f prime x over fx, and also differentiation of ln negative fx is also f prime x over fx. So we can simplify this as integration of f prime x over fx. Okay, we're gonna have ln fx plus c. Okay, so this is integration. If we have the function or the term in form f prime x over fx. Okay, now we look at example 3. Find the following integral. So from this integral, I can see that x is a result of differentiation for x squared minus 1. Okay, so let's say we have fx as x squared minus 1. So when we differentiate fx, so I have 2x. Okay, so what we're gonna do is that for numerator, I put a 2x over here and divide by x squared minus 1 dx. So I just cannot simply put 2 on the numerator. So in order to balance the equation, I have to multiply it with a constant 1 over 2. So this integral is become in the form f prime x over fx. So by using the formula that we learned before, so I can directly integrate as ln fx, which is x squared minus 1 plus c. Okay, so if we can identify the integral in the form f prime x over fx, then we can directly use the basic integral. Okay, for example B, we have integration of x plus 1 over x squared plus 2x minus 1 dx. So for our numerator, what happens is when we have fx as a denominator as x squared plus 2x minus 1, so when we differentiate fx, okay, we have 2x plus 2. Okay, so what happens is if I turn the numerator x plus 1 into 2x plus 2, which is I multiplied with 2, okay, for numerator, so I multiplied as 1 over 2 divided by x squared plus 2x minus 1. Okay, because I want to create the form, okay, this integral into the form f prime x over fx. Okay, so I have here as 2x plus 2 divided by x squared plus 2x minus 1 dx. So by using the basic integration, I can turn this integration into ln x squared plus 2x minus 1 plus c. Okay, but please remember, not all the integration for a fraction can be turned into this form. Okay, so if you cannot change the integral into this form, so we have another method to use.